my speech will be about developing predictive models to identify the bank personnel who are involved in fraudulent activities. Actually, here by fraudulent activities, I mean the personnel stealing money from customer accounts. So, why some personnel do this? Because they feel some pressure about the performance at the business. They have to be that much successful, or sometimes they need some extra money. They need maybe the family member lost her job, and then they need more money. So at this time, this is the motivation part of the process. And then also, if they see any opportunity in the banking system, or there are some weak points that they can cheat, then okay, they have a need, they see the opportunity, and then they, in their brain, they try to rationalize it. Okay, they might think that, okay, I'm a very successful personnel with my performance, the bank this much profit, that much profit, etc. So it would be okay if I steal some of it. They start thinking in that way. So this is what they call the fraud triangle, and once the triangle is completed, they start making fraudulent activities little by little, small by small, and throughout time. In general, these people are very successful, actually successful people, and they know the banking system, its weak points very well, so they can identify the opportunities. But if the bank has maybe 10,000 employees like this, maybe only a few of them can be behaving like that. So the number of fraudulent personnel or fraudulent transactions are very, very little. So the bank I worked for this project was making about 1 million transactions every day. And at that point only, they knew only very few transactions or cases that they had identified. So these fraudulent activities are actually very, very private. The banks do not want them to be known, not to encourage the fraud. But maybe if you're interested, I can give you several examples. For example, once in a branch, there was a personal customer representative who was very successful, and he was giving higher interest rates to his customers. And he was saying to his customer that next time come to me, please, because only I can give you higher interest rate. If you go to another personnel, you cannot get this because the official rate, interest rate is over there. But when the customer said, assume that now the normal interest rate is 10%, he was entering to 12%, 2% more. And he was writing this on the screen. And then on the screen, the interest income is calculated. And then he was taking a print screen, signing it and giving it to customers. But then he was exiting from the screen with escape without confirming. So that money was not in the banking system. It was in his pocket. But he was doing Excel calculations on a site, and when the customer comes back, he was checking from his Excel. Okay, you had this much money, and now it is this much. Okay, now would you like to extend it for another period. Once this was understood, also this person was not going to any holidays because he was working overtime in the lunch, even in the lunch break he was working, in the evening he was working. He had difficulty in going to holidays. In general, these people, fraudulent people, seems to be very hardworking. Once this was understood, it was understood that he stole about $2-3 million from customer accounts. Then, for example, this was easy to prevent. They disabled the print screen function, so this couldn't be repeated again. And then the personnel has 2-3 weeks official holiday every year, and the bank forced each employee to take at least 10 days consecutive holidays, so that once he was away, or he or she is away, if there is anything interesting, then it can be understood better. In another case, for example, one customer representative identified a SME customer, applied for internet banking on behalf of them, and signed the envelope, the contract, got the password, and then having the password on behalf of them, he was making little transfers from time to time. So at the time we started this project, actually I worked on this project for about 5 years. At the time, at the first time when we started this project, we were informed about 15 different cases, two of which I explained as an example. In these cases, 22% was involved, and 46 customers were victims from transfer for money stolen. And in total, in these 15 cases, the person made 351 transactions out of maybe 100 million total transactions. So predicting which of these transactions are really fraudulent is a really difficult task. You know, in data mining or in machine learning, we need positive examples and negative examples. Here, the number of positive examples was very little. So we brainstormed and we discussed how we can solve this problem. And then, since only 351 transactions were not sufficient for a good predictive model, we decided to use other techniques as well, like unsupervised learning. So first we prepared some data mass from some data about transaction details, about the customers involved in this process, about the personnel, and about the relations between the money sender and money receiver. We used the RFM recency frequency monetary technique. We use this on the relation of what is the recency frequency and monetary value between the sender and receiver. Were they making frequently transactions? Or sometimes they prefer dormant accounts, the customer accounts which was inactive for some time. So also we applied the RFM, calculated RFM score for customers only. What was the recency or frequency of the transactions on that customer account? So these two RFM scores, and then we applied anomaly detection technique to customers, for example, as compared to other customers. You know, anomaly detection is kind of clustering. We identify the natural clusters, and then we measure the distance of the customers from the cluster centers. So we measure how abnormal they are, their activities. So we calculate anomaly score for customers, and also we calculate the anomaly score for personnel. So how different that personnel is behaving as compared to other personnel. So these two anomaly scores, two RFM scores, together with the other details about the transaction, we put them on a pot and we developed a predictive score out of these. So this technique seemed to be very good at the time. And what we observed as a result was, for example, anomaly detection is an unsupervised technique. It does not have an ability normally for prediction. But for example, when we check the top percent highest anomaly score customers, we saw them 13 of the 46 customers that was involved in fraudulent activities appeared to be in the top 1% highest anomaly customers. So even we understood that even anomaly detection itself was helpful in identifying where to look. Then the next table, the table is about the performance of the predictive model. For this model, we used a decision tree. For example, in the top 1% of risky transactions, there was 839 transactions, and 219 of them were actually fraudulent activities. So hit was 26%, which is 219 divided by 839. So in total, we had 351 frauds. So the capture rate was 62%, which means it is 219 out of 351 were captured in the top 1% risky transactions. When we go down to top risky 5%, top risky 10% transactions, we saw that in top 5%, we were able to capture 97% of the transactions. And in top 10%, we involved all transactions. So how did we measure this this score? We put this we put all of the fraudulent transactions into the transactions of a single specific day, and top 1% is measured for that day. But normally, of course, we know that we don't have 351 transactions every day, fraud transactions. So this model was used for a couple of years. The inspectors were happy to use that, but there was a major problem because they have some scenarios, they have some rules, they extract some transactions or some people, personnel, and then they also use our score to make an intersection and identify what they will inspect. But out of in their list, they saw that many transactions were getting score of 95, many 90. That was because of decision tree, of course, because in decision trees we have as many distinct scores as the number of difference. So we understand, okay, we should not have used decision trees. So in the next phase of the project, we start working on this again. But this time, maybe there was a little bit more cases. But also we asked the inspectors, okay, what is very worth for you to inspect? Okay, maybe at the end it is not fraud, but in any case, they would like to inspect such transactions. So with that addition, we now had 2,461 transactions that we can label as positive in the predictive model. So since now we had more transactions, we thought that we can now use predictive modeling more instead of anomaly detection. So we developed two predictive models instead of anomaly detection: customer predictive model and personal predictive model. From this we obtained the scores. And then also, as before, we developed and used customer RFM score and relationship RFM score. And then we combined all these models again into the final predictive model for the transactions. For example, I can show you some short performances. For the customer predictive model, in the top 1%, we have 8.4% capture. So in the top 25%, we had almost 60% capture. So it looks not very successful actually, or impressive. In the personal predictive score, we obtained better capture rates, for example, in the top 25%. So this model looked more better than the customer model. So what is important is actually the performance of the last score, which combines everything. So when we look at that, we see that it is much more powerful. Even in the top 1%, we can obtain a 50% capture. So when we go down to 25%, 95% of all fraud transactions can be captured. So in this case, we have a total of 861 transactions, because since we had more than 2,000 examples, we were able to separate training set and test set. So this result is given on the test set, is obtained on the test set. Actually, we were not allowed to include any specific information about the model and model equations. But we made an analysis, and I can say that the most important variables in the three models can be shown like this. For example, in the customer model, the sender customer sending the money, sender current account balance change in the last 3 months was the most important variable. The second one is the sender change in money received from personnel in the last 6 months, because sometimes there are transactions between customers and personnel. And the third one was sender account monitoring number trend in the last 3 months. So sometimes if a personnel is chooses a customer for his activities, he starts going into that account and checking something, maybe checking the signature, maybe he will copy it. So how many times it was monitored was an important variable. For the personnel model, the working together years ratio with the clerk mostly work together. So there are customer representatives and there are clerks. And the physical money transaction is occurred with the clerk. So sometimes if the personnel is doing something, sometimes he has to inform the clerk, or maybe they cooperate. So what is the ratio of the transactions that he uses the same clerk? Was important. Money transfer within bank through digital channels in the last 6 months, and change in number of monitoring of the top account was the next important attribute. For the final model, the transaction suspiciousness score model, the related personnel score, the one of the inputs, transaction risk group, and receiver customer, not sender, this time receiver customer score appear to be the third most important variable. So I quickly summarized what we did in maybe 4 or 5 years. But if you have any questions, I can answer with pleasure.